This video is to solve the problem 1 of homework 3 of probability and stochastic process. And the question gives us the discrete probability distribution of random variable x with respect to k. And the probability of x equals to k equals to b multiplies k multiplies p to the power of k minus 1. And k is from 1 to infinity. And p is within 0 and 1. And question A is to find b so that the probability distribution represents a probability mass function. So here we can simply apply the definition that the sum of a probability mass function equals to 1. So here we have to first calculate the sum of the probability distribution. So here first we write the sum from k equals 1 to infinity of the probability of x equals to k in the form that b multiplies the sum of k multiplies p to the power of k minus 1 from 1 to infinity. Because b is a constant, so we can put it out of the sum. And we expand the sum in the form b multiplies 1 plus 2p all the way until plus the limit of k multiplies p to the power of k minus 1 as k approaches infinity. And we call this equation 1. And we can get equation 2 by multiplying both sides of equation 1 by p. And we get p multiplies the sum of the original probability distribution equals b multiplies p plus 2p squared all the way until the limit of k multiplies p to the power of k when k approaches infinity. And we call this equation 2. And by using equation 1 minus equation 2, we get 1 minus p multiplies the original sum equals b multiplies the limit of 1 minus p to the power of k minus 1 divided by 1 minus p minus k multiplies p to the power of k as k approaches infinity. And as k approaches infinity, we can simply eliminate this limit to the form b divided by 1 minus p so that we get the original sum of the probability distribution equals to b divided by 1 minus p squared. Moreover, we know that the sum of the probability distribution equals 1, so that b divided by 1 minus p squared equals 1, so that we get b equals 1 minus p squared. So this is the answer to the first question. And the second question wants us to find the mathematical expectation of random variable x. So first, from question A, we can know that the sum of k multiplies p to the power of k minus 1 from k equals 1 to infinity equals 1 divided by 1 minus p squared. And we multiply this equation by p on both sides, and we get the sum of k multiplies p to the power of k equals p divided by 1 minus p squared. And here we're taking the derivative of p to the equation on both sides, and we can get this equation, because k multiplies p to the power of k, taking the derivative of p equals to k squared multiplies p to the power of k minus 1. That is the left side of the equation, and the right side of the equation can be rewritten into 1 plus p divided by 1 minus p to the power of 3. And we call this equation 3. And here we can finally calculate the expectation of random variable x, which is equal to the sum of p multiplies the probability distribution of random variable x from k equals 1 to infinity, which is equal to 1 minus p squared, because in question A we have calculated that b equals 1 minus p squared, multiplies the sum of k squared multiplies p to the power of k minus 1 from k equals 1 to infinity. And here we apply the equation 3 we have just calculated, and we get the result that the expectation of x equals to 1 plus p divided by 1 minus p. And that is the answer to the question B. And question C is to find the expectation of x squared. And similarly, we apply the approaches in question B to question C, and we can compute that the expectation of x squared equals to k squared multiplies the probability distribution of x from k equals 1 to infinity, which is equal to 1 minus p squared multiplies k to the power of 3 multiplies p to the power of k minus 1 from k equals 1 to infinity, which is equal to 1 minus p squared. And here, this part equals the previous steps this part, because if we take the derivative form of p to p multiplies the sum of k squared multiplies p to the power of k minus 1 from k equals 1 to infinity, we can see that this part is k squared multiplies p to the power of k, and we taking the derivative with respect to p, we can get k to the power of 3 multiplies p to the power of k minus 1. So here, this is the equation 3 we have computed in question B. So here we simply apply the equation 3 to this equation, and we can get this part equals to 1 plus 4p plus p squared divided by 1 minus p to the power of 4. And finally, we can calculate that the expectation of x squared equals to 1 plus 4p plus p squared divided by 1 minus p squared. And that is the answer to the question C. And question D wants us to find the mathematical expectation of x squared minus the square of the mathematical expectation of x. So we simply apply the results of question B and question C to this question, and we can get the mathematical expectation of x squared minus the square of the mathematical expectation of x equals to 1 plus 4p plus p squared minus 1 minus p squared divided by 1 minus p squared, which is equal to 4p plus 2p squared divided by 1 minus p squared. And that is the answer to the question D. And question E, suppose that p equals 1 out of 3, and this question wants us to find the conditional probability mass function of x equals to k when x within 2 to 5. So here we can first use p equals 1 out of 3 to calculate b equals to 4 out of 9. And we further compute the probability of x within 2 to 5 is equal to applying the very first probability distribution function. This probability is equal to 4 divided by 9 multiplies the sum of 3 to the power of 1 minus k multiplies k from k equals 2 to 5. And this probability equals to 392 out of 729. So we can compute the probability of x equals to k, provided that x is within 2 to 5 equals to, according to the definition of conditional probability, the probability of x equals to k and x is within 2 to 5 divided by the probability that x is within 2 to 5, which is equal to 4 out of 9 multiplies 3 to the power of 1 minus k multiplies k divided by 392 out of 729, which is just calculated by us. And we get a result. 81 out of 98 multiplies 3 to the power of 1 minus k multiplies k. And this distribution applies for x equals to 2, 3, 4, and 5. And for other situation, the conditional probability distribution, the conditional probability mass function equals to 0. So these two equation is the answer to the question E.